In most buildings, ground sills are driven vertically into the ground to provide stability and some resistance against earthquakes. In the Hanging Temple, the ground sills are driven horizontally into the mountainside. Thus, the cross beams find their support in the hard rock of the mountain. But just how solid and stable are these ground sills? A simulation can demonstrate. This is a mountain. The cross beams are driven into it with a part protruding. Then the model building is placed on top. A tempest. The cross beams break and the model collapses. Clearly, these ground sills are not sufficiently strong enough. So, what else could have been used to support the temple? The fact is, a small part of the yellow rock supports the temple structure. Moreover, the many grottos make the temple a half-constructed, half-excavated structure, which is given firm support by the mountain below the grottos. The rock, although it cannot be observed from below, combines with the cross beams to form the horizontal ground sills and bear the weight of the Hanging Temple. The cross beams connect the main body of the temple to the mountain to create a structural whole. So, despite its apparent vulnerability, the temple is leaning safely on the mountainside. The 1 meter of crossbeams outside the main body is actually only a small part of the temple. The main part of the crossbeams is hidden in the cliff. The meter of protruding crossbeams does support something: the walkways. The walkways, although in themselves don't weigh too much, they still have to bear the weight of many tourists. This is where the columns beneath play their role. The tops of the columns support the cross beams, while their bases stand hard against the rock. Together, the columns and the cross beams form a strong support system. The standing points of the columns are all carefully designed. Some of the columns shoulder the weight, and some adjust the height of the various halls. Interestingly, the columns beneath the walkways normally bear no weight. They begin to function only once the weight has passed a certain limit, so there is no need to worry that too many visitors might cause it to collapse.
这一部分啊，它是2个3层楼阁，这一块这一块，上面是用一个木栈道连接起来。这个木栈道啊，它是靠这个横梁而插到这个岩石里边，它的支撑作用啊，是这个靠它的背力而支撑。我们看到这个立柱啊，它是一个辅助的作用，实际上呢，它能晃。
How the crossbeams were installed is an intriguing question. In the 1980s, archaeologists accidentally discovered 2 lines of square holes in the steep cliff on the south side of the valley. They follow a straight line, apparently leading outside the valley. The experts thought they might be the remains of suspended roads. Historical records show that in olden times, Mount Hung was a coveted natural defense system. The Wu Di, Tuabagui of the Northern Wei dynasty, some 1600 years ago, dispatched a force tens of thousands strong to the area to open up a passage for an advance into central China. Some 6 centuries later, Yang Yu and his family guarded the area against enemy invasion. The remains of the suspended roads originate from this era. The suspended roads built on the steep cliffs were a key military transportation route. In the Zhang Guoqi, The Strategies of Qin, it says, suspended roads extended for hundreds of kilometers to the territory of Shu. This dates the suspended roads on the cliffs to more than 2,000 years ago. The first process in building a suspended road was to drill holes into the cliffs. Crossbeams would be driven into them, on top of which boards would be laid. Thus the natural defenses were transformed into a passage. Suspended roads generally had to be built in particularly dangerous areas, and the projects tended to be fraught with difficulties. Because of this, they are considered a wonder of China's transportation construction history. The suspended roads were used originally to convey both supplies and military intelligence. Many years later, they would carry an architectural wonder.
这个木质结构呢，它是在山体上打上窟窿，把木结构插进去，形成飞梁，在飞梁上边接着是楼阁和栈道。
But how were the holes drilled 1,500 years ago without the aid of modern mechanical tools? The tools available at the time consisted of just chisels, either round or flat. Drilling the 27 holes for the temple's crossbeams using such simple iron tools was undoubtedly a daunting challenge. First, the craftsmen had to make the holes. That done, they would insert the crossbeams. Even though the support comes from solid rock, it's still remarkable that the crossbeams are so stable. The mystery of the crossbeams' stability was finally solved in the 1990s, when some of them had to be replaced. At first it proved impossible to remove the crossbeams. Eventually, it was discovered that the holes were not square, as was originally thought, but trapezoidal. The triangular extension gave the beams greater stability. Alongside each crossbeam, a wedge was hammered into the rock. The deeper the wedge was hammered in, the tighter it stuck.